Electrical conductors must be derated, meaning their ampacity must be reduced under certain conditions as specified by the National Electrical Code, or NEC. Two primary reasons for derating are firstly, when installed with more than 3 current carrying conductors in a raceway, which is a conduit or pipe designed to hold wires, and secondly, when installed in a raceway exposed to ambient temperatures above 86 degrees Fahrenheit or 30 degrees Celsius. The NEC provides specific derating factors to account for these conditions. For 1 to 2 conductors in a raceway, no derating is required. The conductors can carry 100% of their rated ampacity. For 3 to 4 conductors, the ampacity must be derated to 80%. For 5 to 9 conductors, it's derated to 70%. For 10 to 20 conductors, the derating factor is 50%, and for 21 or more conductors, it's 40%. To understand the implications of derating, consider a scenario with 3 200 amp sub-panels connected to trough using conduits. If each sub-panel supplies current through a conduit containing 3 current-carrying conductors, the ampacity must be derated to 80%. This means each 200 amp sub-panel can effectively supply a maximum of 160 amps, calculated as 200 amps multiplied by 0.80. If there are 3 such sub-panels, the total combined current they supply is 3 times 160 amps, equaling 480 amps. The size of the conduit also plays a critical role. A 2-inch EMT conduit typically has an ampacity of 200 amps. If the total current from the sub-panels, which is 480 amps, exceeds the conduit's ampacity, multiple conduits are necessary to distribute the load safely. In this case, at least 2 2-inch EMT conduits would be required. Now consider using 14/2 Romex wire on a 15 amp circuit within this setup. The NEC specifies wire sizes based on the circuit's ampacity. For a 15 amp circuit, 14 American wire gauge, or AUG, wire is generally recommended. However, because the conduits are subject to derating, the wire's ampacity within the conduit must also be derated. Using the 80% derating factor, the effective ampacity of the 14 AWG wire in the conduit is 15 amps multiplied by 0.80, which equals 12 amps. Given these derating requirements and the conduit's ampacity, it's typically not permissible to use 14/2 Romex on a 15 amp breaker in such an application. The derated ampacity of the wire is less than the breaker's rating, which could lead to overcurrent and potentially hazardous conditions. To ensure safe and code-compliant operation, it's necessary to use a larger wire size such as 12/2 Romex, which has a higher ampacity. This ensures that even after derating, the wire can safely handle the circuit's current demand. It is important to consult the NEC tables for specific ampacity ratings of different wire sizes and conduit types, as these values can vary based on factors such as insulation type and temperature rating. These tables provide the necessary information to perform accurate derating calculations and select the appropriate wire and conduit sizes for a given application. Additionally, consider ambient temperature when derating conductors. If the ambient temperature exceeds 86 degrees Fahrenheit, additional derating may be required. The NEC provides temperature correction factors to adjust the ampacity of conductors based on the ambient temperature. For example, if the ambient temperature is 104 degrees Fahrenheit, the ampacity of the conductor may need to be reduced by an additional percentage, as specified in the NEC tables. Furthermore, ensure that the conduit fill is within the limits specified by the NEC. Conduit fill refers to the percentage of the conduit's cross-sectional area occupied by the conductors. Overfilling a conduit can impede heat dissipation and lead to overheating of the conductors. The NEC specifies maximum conduit fill percentages based on the number and type of conductors in the conduit. To calculate conduit fill, determine the cross-sectional area of each conductor and the conduit, and then calculate the percentage of the conduit's area occupied by the conductors. Ensure that this percentage does not exceed the NEC limits. In summary, derating electrical conductors is essential to ensure safe and code-compliant operation. Factors such as the number of current-carrying conductors in a raceway, ambient temperature, and conduit fill must be considered when determining the appropriate wire and conduit sizes. Always consult the NEC and relevant tables to perform accurate calculations and select the correct components for the specific application. Ignoring derating requirements can lead to overheating, insulation damage, and potentially hazardous conditions such as electrical fires. By following the NEC guidelines and performing thorough calculations, you can ensure that your electrical installations are safe, reliable, and compliant with industry standards. Moreover, remember that local codes and regulations may have additional requirements or restrictions beyond those specified in the NEC. It is always advisable to consult with a qualified electrical inspector or engineer to ensure full compliance with all applicable codes and regulations. They can provide valuable guidance and expertise to ensure that your electrical installations meet the highest standards of safety and quality. In addition to the derating factors mentioned earlier, it's also crucial to consider voltage drop when selecting wire sizes. Voltage drop refers to the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the conductor's length, the current flowing through it, and its resistance per unit length. Use the appropriate formula to calculate the voltage drop and ensure that it remains within the NEC recommended limits. If the voltage drop exceeds these limits, you may need to increase the wire size to reduce its resistance and minimize the voltage drop. Furthermore, when installing conductors in parallel, it's essential to follow the NEC guidelines for parallel installations. Conductors are often installed in parallel to increase ampacity and reduce voltage drop. However, the NEC imposes specific requirements to ensure that parallel installations are safe and reliable. Firstly, all parallel conductors must be of the same length, material, and insulation type. Secondly, they must be terminated in the same manner. Thirdly, they must have the same ampacity rating. Fourthly, they must be installed in the same raceway or cable. By following these requirements, you can ensure that the current is evenly distributed among the parallel conductors and that the installation is safe and code compliant. Another important consideration is the type of insulation used on the conductors. Different types of insulation have different temperature ratings and ampacity values. The NEC specifies the allowable ampacity for various insulation types based on their temperature ratings. Ensure that the insulation type you choose is suitable for the operating temperature of the application. If the operating temperature exceeds the insulation's temperature rating, the conductor's ampacity must be derated accordingly. In addition, be aware of the different types of raceways and their limitations. EMT, or electrical metallic tubing, is a common type of raceway used in electrical installations. It is lightweight, easy to install, and provides good protection for conductors. However, EMT has limitations on its bending radius and the number of bends allowed in a run. The NEC specifies the minimum bending radius for EMT to prevent damage to the conduit and conductors. Also, the number of bends in a run should be limited to reduce friction and make pulling conductors easier. Other types of raceways include rigid metal conduit, or RMC, which is stronger and more durable than EMT. It is often used in applications where greater mechanical protection is required. PVC conduit, or polyvinyl chloride conduit, is non-metallic and resistant to corrosion. It is often used in underground or wet locations. Each type of raceway has its own set of advantages and disadvantages, and the choice of raceway should be based on the specific requirements of the application. When pulling conductors through raceways, use appropriate pulling lubricants to reduce friction and prevent damage to the insulation. Follow the manufacturer's instructions for the lubricant and apply it liberally to the conductors as they are being pulled. Avoid using excessive force when pulling conductors, as this can damage the insulation or the conductors themselves. If you encounter resistance, stop and investigate the cause before proceeding. It may be necessary to use larger pulling equipment or to reconfigure the raceway to reduce the number of bends. After the conductors are installed, properly terminate them at the appropriate electrical devices, such as circuit breakers, switches, and receptacles. Use the correct tools and techniques to ensure that the terminations are secure and that the conductors are properly connected. Loose or improperly terminated conductors can cause overheating, arcing, and potentially hazardous conditions. Finally, always inspect your electrical installations thoroughly before energizing them. Check for any signs of damage, loose connections, or other potential problems. Use appropriate testing equipment to verify that the circuits are properly wired and that there are no ground faults or short circuits. If you find any issues, correct them before energizing the system. By following these guidelines and paying close attention to detail, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. Remember, electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the installation. They can provide expert guidance and ensure that the work is done safely and correctly. In conclusion, understanding and applying derating requirements is crucial for safe and code-compliant electrical installations. The NEC provides specific guidelines and tables to help you determine the appropriate wire and conduit sizes for various applications. Factors such as the number of current-carrying conductors, ambient temperature, conduit fill, voltage drop, and conductor insulation type must be considered. By following these guidelines and consulting with qualified professionals, you can ensure that your electrical systems operate safely and reliably for years to come. Always prioritize safety and never compromise on quality when working with electricity. Electrical safety is everyone's responsibility, and by taking the necessary precautions, you can protect yourself, your family, and your property from electrical hazards. Remember to always turn off the power before working on any electrical circuits and to use appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. They have the knowledge, skills, and experience to perform electrical installations safely and correctly. By following these guidelines and taking the necessary precautions, you can ensure that your electrical systems are safe, reliable, and compliant with all applicable codes and regulations.